In early 2020 it became clear that we were headed into a long period of lockdown, and our dog Wisley, and this is him, became ever more important to our household's health and sanity. I also thought we could have some fun by mapping his walks using an old GPS tracker I used to use for mapping snowboard adventures and making trail maps. Working from home continued, and mapping Wisley's walks became a bigger project. In part 1 here we're going to explore some simple ways to map Wisley's data. We started the adventure March 16th, not knowing quite when it would finish, and once we got to a year on March 15th 2021, I decided a year's worth of data would be enough. We've captured 730 walks across a year of morning and evening walks, so join Wisley and I for a walk through his walks. And here's Wisley's very first morning walk from March the 16th 2020. As you can see, it's a loop, and it's a series of waypoints that I downloaded each day from the GPS unit in GPX format. In ArcGIS Pro, I could then go to the geoprocessing tool GPX to features, and that allowed me to extract the waypoints that included dates and create a feature class. I could then use the point to line tool to create the tracks, and here's that very first walk as a polyline. It's been cleaned a little bit. I took out various stops along the route to preserve his modesty, and I basically used some cartographic generalization tools to simplify the line and smooth the line and to make it look a little bit more aesthetically pleasing. Once I had all 730 individual tracks, I used the merge tool to create one feature class of all walks, and here they are, overlaid as a map of Wisley's entire year of walks. At this scale, the lines seem to coalesce. Many routes were walked many times, some only once, but if we zoom in into one of his favourite local parks, you can see more clearly the structure of the data. Even on favourite repeated routes, he took a different line, so there's a natural thickening of the line where he's walked the same route multiple times. Taking a quick look at the attribute table for the layer shows each walk length in metres, the date of the walk. Some characteristics like whether it was a morning or afternoon walk, and some additional daily weather conditions which we'll use later. Because the map was going to be public, one of the key things I wanted to ensure was an element of data privacy, so making maps of Wisley's walks became a challenge not only cartographically, but with an eye on ensuring our home wasn't obviously identifiable. To that end, there's no base map or other major identifying features. So what questions can we ask of the data? What can we do cartographically to tease anything meaningful out? What can actually be seen? Coincident and overlapping features are a common problem for cartographers. Well, we can use simple definition queries to create time of day ranges, and we can see there's a difference between where Wisley walks in the mornings compared to the afternoons. He prefers shorter morning walks and longer evening walks, and as with the map of all routes, the simple overlay of his routes leads to brighter and thicker, meaning a more commonly used route. I've changed the symbology here in comparison to the maps you've seen so far, and opening the symbology pane reveals that each line is in fact made up of 4 solid stroke layers. Starting at the bottom, there's a 2-point yellow line, and that also has 98% transparency applied to it. Above that, there's a 1-point line with exactly the same colour and transparency applied. And there's another slightly thinner yellow line at the top of that, and at the top of the stack a 0.25 point white line with 90% transparency. With a lot of overlapping lines, the use of transparency in particular helps us to achieve an additive effect for coincident lines that builds at smaller scales to create a better sense of routes that are more common and which solid lines cannot similarly achieve. Let's go back to that small park, see the difference between the routes symbolised with transparency and the original with the single symbol layer with no transparency. Of course, perusing the attribute table and creating summary statistics gives us an additional useful information. The shortest walk he did in lockdown was in May 2020 at a whopping 740 metres there and back, but he made up for it, and his preference for walking loops with his longest walk at 7.4 kilometres, which is about 4.6 miles in February 21. The sum of his walks is 1,332 miles, and we can tease these out using definition queries, and juxtaposing these on the same map can be achieved using categorical colours to signify one route as different from another. Here, yellow for his longest walk, which was a big loop, and blue for his shortest walk, which was literally there and back. And we know from experience that Wisley's affected by the heat. I mean, so would you be if you went on a walk in the height of summer when temperatures regularly top 40 degrees Celsius, that's over 100 degrees Fahrenheit. More simple definition queries on those additional fields in the attribute table for days with an average temperature less than 20 Celsius, and the equivalent for days over 35 Celsius, give us these two maps, again symbolised to reflect the weather conditions of cooler and warmer. Seeing what we already knew confirms his behaviour. Does a bit of rain change the routes he chooses? Well, there aren't many rainy days in SoCal, but he loved them. Some of his longest walks, as you can see there, were in the wet, compared to the more common dry days in the yellow. And that completes our first look at Wisley's walks, just mapping simple aspects of the data.